0.1b, the significance test for goodness of fit, chi-squared. Does the warm, sunny weather in Arizona affect a driver's choice of car color? Cass thinks that Arizona drivers might opt for a lighter color with the hope that it will reflect some of the heat from the sun. To see if the distribution of car colors in Oro Valley near Tucson is different from the distribution of car colors across North America, she selected a random sample of 300 cars in Oro Valley. The table shows the distribution of car color for Cass's sample in Oro Valley and the distribution of car color in North America. This is according to ppg.com. So we have all of North America, and then we have our sample from Oro Valley. So they have some claim about the parameter, like all cars, and then we have our sample, and we're seeing, is this distribution of color close enough to what we'd expect, or do we have evidence that this distribution of color is different? Do these data provide convincing evidence that the distribution of car color in Oro Valley differs from the North American distribution? So our hypotheses we're going to write in words. The distribution of car color in Oro Valley is the same as the North American distribution. Alternative, the distribution in Oro Valley is not the same. And we'll state our significance level. Alpha is 0.05. 5% significance level. The name of the procedure is a chi-squared test for goodness of fit. And we will check our conditions. 3 conditions to check: random, large count, and then also 10%. It is a random sample of 300. This lets us generalize to all cars in Arizona since we randomly selected 300 from that population. All expected counts are greater than or equal to 5. The smallest expected for green is 6, which is greater than or equal to 5. Make sure you compare the smallest one to 5 and state that all of them are more than 5. That lets us use the chi-squared test statistic and use chi-squared to model the distribution of test statistics. And then the 10% condition, we are sampling without replacing. So because 300 is less than 1/10 of cars in North America, and we are good there. Let's actually make this number of cars in Arizona, because that's the population from which we selected the 300, actually. Let me get back to you on that one. All right, so a specific formula. Your chi-squared is the sum of observed minus expected squared divided by expected. Here's the work to calculate it. So 84 minus 69 squared divided by 69. You have all the ones in the middle. So what you're doing is you have a sample of 300. You observed 84 white cars, but you would expect 23% of 300. So let's see what that is. 300 times 23.23, 69. So you would expect 69 cars to be white, but actually 84 were. So when you're calculating that test statistic, 84 minus 69 squared divided by 69, and you go ahead and you do that for each one. And green was the smallest expected. Your test statistic is 29.92. We'll draw our picture, our chi-squared distribution. 29.92 is way far away from 0. Remember, the mean of a chi-squared distribution will be the degrees of freedom of 8. So our test statistic, 29.92. And if we calculate our p-value on table C or do chi-squared CDF with this lower bound of 29.92, our upper bound infinity, and a degrees of freedom of the number of categories minus 1. So we had 9 minus 1, degrees of freedom is 8. Okay, so we have significant results. So in our conclusion, since the p-value is less than alpha, we have sufficient evidence to reject the null hypothesis and conclude the distribution of car color in Oro Valley is not the same as it is in North America. If there's convincing evidence, we will do a follow-up. So the largest contribution to the chi-squared test statistic came from other, which was 18 more than expected, and gray, which was 17 below expected.